Hello everyone, I am Shruti Vijayvargi from BISP Solutions. My topic is Excel Financial Function, and this video I am showing the category of internal rate of return functions. The internal rate of return functions includes IRR, MIRR and XIRR functions. So first is the IRR, which stands for the internal rate of return. Internal rate of return is the interest rate at which net present value of all cash flows, both positive or negative, from a project or investment equals to zero. Internal rate of return is used to evaluate the attractiveness of a project or investment. That is, it is a set of values which includes the initial investment value and a series of net income values. The internal rate of return indicates the profitability of an investment, and therefore it's commonly used in business when choosing between investments. This measurement is a series of cash flows and including initial investment along with the net income over a number of periods to calculate the compounded return, assuming the net present value of the investment is zero. Suppose we have a collection of pairs like time and cash flows involved in a project. The internal rate of return follows from the net present value as a function of the rate of return. A rate of return for which this function is zero is an internal rate of return. So what I am trying to say is that when the NPV is calculated and the value of NPV becomes zero, then it becomes the internal rate of return. So this is how NPV is calculated, and if the calculation represents answer 0, then it is internal rate of return. So we don't need to calculate NPV in Excel, we just calculate it using the function of IRR, which takes two arguments. The first one is the values is a reference to a range of cells containing the series of cash flows, investment and net income values, and it must contain at least one positive and at least one negative value, one positive and one negative value. The negative value is the investment done by us because it represent by negative sign because it the income which goes out from our account, and the positive value represent the money which comes into our account. Okay, the next argument is the guess value. It is also an initial guess at which you think the IRR might be, and if we omit the guess value, and this value will takes the 10% default. So let's understand it with the help of an example. I have an example of IRR. Here the initial investment of $100. In Excel, the negative values are represented in parentheses. This is a negative value and it represents by negative sign because it is the investment done by us, so it is negative. Then year 1 income will be $24, year 2 income will be $24, year 3 income will be $28.80, and year 4 income will be $34.56, and year 5 income 41.47. Now, if we want to calculate the IRR after 3 years, then we just select the cell, type an equal sign, write the IRR function and pass the arguments. Because here we are calculating IRR for 3 years, so I am passing the references from initial investment to the third year incomes from D3 to D6, and then write parenthesis enter. So this is the IRR value after 3 years. If we want to calculate the IRR for all the 5 years, then just select the cell, type an equal sign, select the function and type values from initial investment to the last cell from D3 to D8 and enter. So this is the IRR value after 5 years. So this is how IRR is calculated in Excel. The next function I am going to explain is MIRR, which stands for the Modified Internal Rate of Return. The Modified Internal Rate of Return is a financial measure of an investment's attractiveness. It is used in capital budgeting to rank alternative investments of equal size. As the name implies, MIRR is a modification of the internal rate of return, and as such, it aims to resolve some problems with the IRR. There are some problems with IRR, so MIRR is developed. It is a set of values which includes an initial investment value and a series of net income values. So here is the formula of MIRR. Original calculation is done like this, and root root FV positive cash flows reinvestment rate divided by PV negative cash flows finance rate minus 1, where N is the number of equal periods at the end of which the cash flows occur, PV is the present value at the beginning of first period, and FV is the future value at the end of last period. The formula adds up the negative cash flows after discounting them to time zero using the external cost of capital, adds up the positive cash flows including the proceeds of reinvestment at the external reinvestment rate to the final rate, and then works out what rate of return would cause the magnitude of the discounted negative cash flows at time zero to be to the future value of the positive cash flows at the final time period. So let's first discuss the problems with IRR, then I will show the example of MIRR and Excel. Many organizations rely on the IRR as a measure of the success of a project. There are, however, some technical issues with using the IRR function in Excel, as well as some general issues that the user should be aware of. The first problem with the IRR is the multiple solutions, and the first cash flow is a negative. If the first cash flow is a negative, the IRR will have more than one solution, and Excel will only display the first one which it finds. Similarly, each time the cash flow changes from positive to negative, another possible solutions for the IRR is created, and Excel will only display the first one which it finds. So use the guess feature to try and guide Excel to the correct result. Another option is to use the MIRR function in Excel, which requires assumptions for the reinvestment rate and finance rate. The second problem with the IRR is the no solution. And if Excel has to go through more than 20 iterations to find the IRR, it will come up with #num error value. And IRR function expects at least one positive cash flow and one negative cash flow, otherwise it returns the #num error value. The last problem with the IRR is the false solution. Even if net cash flows are negative, Excel can produce positive IRR. Okay, so if cash flow don't occur in the correct order, that is negative followed by the positive, then the IRR produced can be false. For example, if cash flows at the beginning of the project are small and positive, and at the end of the project are large and negative, the IRR will necessarily need to be high to reduce the net present value of the latter cash flows. Okay, so these are the problems which we are dealing and MIRR is developed. So here's the formula of MIRR, which takes three arguments. The first one is the values is a range of cells that represents the series of cash flows. Then we have the finance rate. It is the interest rate that you pay on the cash flow amounts. And then reinvestment rate. It is the internal interest rate that you receive on the cash flows amounts as they are reinvestment. So let us look at the example of MIRR. Here I have the values. First one is the initial investment, and it is represented by negative sign, and in Excel negative values are represented in parentheses, which of 7,500. Then after year 1 income will become 3,000, year 2 income will become 5,000, year 3 income will become 1,200, year 4 income will become 4,000. And we have the finance rate of 5% and the reinvested rate of 8%. So MIRR becomes calculated as select the cell, type an equal sign, select the function, and pass the values including initial investment to the end year from D4 to D8. Then finance rate here is of 5% and reinvestment rate of 8%. Then write parenthesis. If all values are correct, then MIRR will calculate it. So this is how MIRR works. Now the next function I am going to explain is XIRR. The It stands for the internal rate of return for irregular cash flows. The IRR does not solve one problem, and that is when the payments are at irregular interval. So in this case, we use XIRR. IRR and XIRR are very important terminologies that will help you to understand the returns on your investments in more detail. IRR is used to calculate the returns given some amount at a fixed interval. The only difference between XIRR and IRR is that IRR consider periods of equal durations, that is year 1, year 2, year 3, and XIRR allows periods with different durations. The Excel XIRR function returns the internal rate of return for a supplied series of cash flows, that is a set of values which includes an initial investment value and a series of net income values which are not necessarily periodic. So here is the calculation of XIRR. When this value becomes 0, then it is the XIRR. But in Excel, it just takes three arguments. First one is the values. It is a reference to a range of cells containing the series of cash flows, investment, and net income values. It must contain at least one positive and at least one negative value. The second argument is the dates. It is a series of dates corresponding to cash flows. The first date is the start of the loan investment period, and the subsequent dates refers to the income values. Therefore, subsequent dates must be later than the first date. Problems can occur if dates are not entered in the right format. XIRR will return the hash value error. Next is the guessed value. It is an optional argument which is omitted, takes on the default value of 10%. So I have an example of this function. Here is the date. The cash flows are represented here. This and this value are represented by negative sign because both these values are of investment. This is the values which goes out from our account. So they are represented by negative sign, and Excel negative values are written in the parentheses. And after that, these three values and these three values are the incomes we have gained for this dates. So XIRR will calculate in Excel by selecting the cell, type an equal sign, select the function, and pass the values references from cell F6 to F13, pass the dates, and then enter. So it is 0.07%. So this is how internal rate of return functions works. If you like my videos and if you understand all these functions, then thumbs up my video, and if you have any doubts you can comment me. Thank you.